Welcome back. I'm the IT Kid, and we're going to be continuing our ultimate guide to learning Python. This week, we'll be covering data types. Data types are the fundamental building blocks in which we use for all of our code, whether it's in Python, Java, C++, etc. It doesn't matter what coding language you're going to use. You'll most likely have to talk about or use data types because they build up everything else that you do. Now, what are some of the examples of data types? In Python, the most basic ones and the ones that we need to know for now are strings, which are things that are enclosed by double quotations or single quotations. So a space can be a string, anything within the boundary of those quotations, or if you write hello within that boundary, that is also a string. Strings are just sequence-based data types put within the space of two quotations. The next data type we'll be covering is int. Ints are simply numbers. Any number that you can put inside is an int, except for decimal-based numbers. So if you have 3, that's an int. If you have 5, that's also an int. If you have negative 42, that is an int. Wow, that is an ugly 42. But it's not very hard to grasp. They're numbers. They're real numbers. And then you have decimals or floats or doubles. And doubles are, or I guess in Python it would be more accurate to call them floats. Floats are basically integers, except they have a decimal point with a decimal place after it, or even just something like 3.0. And floats and integers, it'll be very important to discern between the two of them because it'll be important whenever you're doing operations within your code later on. And then the last one we'll be talking about in this video is going to be Booleans. Like I said at the end of the last video, Booleans are all true or false. If it falls within these two categorizations, it is a Boolean. It is simply either true or it is false. So I'm going to show you some use cases of all the different data types. If you're in Python and you want to print out a word, you'll basically have that word and you'll assign it to a variable. You create a variable name, and then you'll set it equal to some value within those quotation marks. And that's how you assign a string to a variable. You can do the same with any other data type. You can make it an integer 3, that looks ugly. You can make it an integer 3.0, or you can make it equal to true or false. The thing about a variable, though, is it cannot be two data types at the same time. You can change the data type, and there are things you can do to, convert from one data type to another, although this might not be true for all instances, and it's definitely a little bit more complicated than what we'll be talking about today. Now we'll go into Spider and we'll actually look at some real applications of the code. Okay, so here we are in Spider. We'll be looking at some real applications of code now. There are some basic things which will be very fast to go over. So if you want to create a variable, you set a variable name, and then you have that equal to some kind of data type. Like I said, if you want it to be string, it can be hello, or you could set the name equal to an integer of some sort. You could set the name equal to some float value, or you could set the name equal to true or false. And the key thing to remember when assigning variables is that you do not want multiple variables with the same name. Otherwise, the compiler won't know which one to reference, and it'll throw an error in your code. So when you're assigning a variable, make sure that you have one data type to a variable. Do not give multiple. Well, when I say the compiler won't know which one to reference, it's not like it'll run an error in the code fundamentally. It's that you're overriding what the variable is called. So if I have a variable name like here equal to hello, and I have the exact name here equal to 20, what it's going to do is that it'll set variable name equal to 20. And if I did the same thing again, it's going to set it equal to 24.5. So it'll override what the last variable was, and it'll change it to this new value that you have afterwards. So you want to keep the names different unless you're purposefully trying to change it. And the second thing is print functions. So a print function, if you set it like so, a print function displays whatever the variable or whatever you put in the print statement inside the console. I'm sure most people know what this is, and most people know how this works. You click play, it'll type in whatever is in the confines of the print statement. Here, because we have variable name, it prints what's assigned to variable name, which is hello. Over here, because we put a literal in by typing hello world within quotation marks, it prints the string hello world. So we know what data types are. We know how to assign them to variables. We know how to physically display them. Why are they important? Variables, in more than many ways, will make up everything that you want to do. Outside of just print statements, you want to assign a certain variable to some kind of object if you're doing an operation. One example would be here. If you want to do some kind of math and you need to assign different variables, you might want to do like n equals to 5, m equals to 23, and z equals to 17. And so maybe you have some equation, and if you want to find out what is n times m divided by z, this can be a very useful way of shorthanding it. Instead of having to write some array of numbers constantly or some array of values, it can be a good way to shorthand it. Of course, you want to add the equal sign, of course. And like so, if I go to print equation, it'll do the math within the confines of the variable assignment, and then it'll print out that equation itself. The answer is 6.76475, etc., etc., etc. Now, what if this was a float? Whenever I was saying that you want to have just one, or not that you want to just have, but you can only have one data type assigned to a variable at a time. When you have multiple data types interact with each other, there are some specific interactions that can happen. Although in many instances, it will just throw an error. But in this case, floats and integers are able to work together because they're number-based sequences or number-based data types. And if it compiles the equation and then prints out, it will return a float like it did before, because this is the very literal, it's a very literal equation. Okay, so we know that a float and an integer can work together. It'll just throw out the very literal answer to the equation. If you have it in an instance where you remove the times z, right? And then you have 23, and you multiply these two together, you get 115. If you then add the float, the final result will also be a float. That there's no exception to that. if you multiply a float by an integer, the final answer will be a float. Now let's look at some instances of data type interactions that won't work. If you have m equal to 23, but within the quotation marks, this is no longer an integer, nor is it even a float if you add the decimal point. This will always be a string. So if you go to sum up the equation and then print out that equation, you will get something that's not what you expect. It's not going to give you 5 times 23 in the sense of the equation. It's going to multiply the string 23 5 times. So you'll have the first instance of 23, then you have the second instance, and then you have the third instance, then you have the fourth instance, and then you have the fifth instance. Yeah. So equations and data type interaction, there are many very unique cases to look at. Not all of them we can cover in this series, but this is a certain instance where instead of getting what you would expect of 5 times 23, you get 23 5 times. So what if we then assigned true to m? M is equal to true, equation equals n times n, and then we print out equation. We're simply getting 5, and that is because in this instance, what Python is doing is it's representing this Boolean value as an integer expression. In Python, true is equal to 1, and false is equal to 0. If you know about binary and you know about on and off, true or false, this is what these mean. True is equal to 1, false is equal to 0. So because m is equal to true, and we're multiplying it by an integer, Python's like, oh, we're doing integer multiplication. It assigns true equal to 1, and you get 5. If we were to put false here, you will not still get 5. You will get 0. And as you see, you get 0. Main thing to consider when using data types is be careful about what data type you might want to be using, what interactions you might want to have. If you want to do some kind of complex equation, solve some kind of complex data set, if you want to print out a sequence of letters, a sequence of statements. And a good exercise to practice now that you know some data types is experiment. Go assign a bunch of variables, give them a bunch of data types, give them integers, give them floats, give them booleans, give them strings, and then try to print out those statements. Try to see how they interact with each other and find out a bunch of cool stuff that you can do with them. And if you do find any cool interactions, make sure to leave them in the comments. I'll be sure to respond to any comments below. That's it for this video. Next week, I think we'll start to cover some for and while statements. So that's something to be excited for. I'll see you in the next video.
Hopes